In this question we need to show that the diagonals of a square are equal and bisect each other at right angles. That means we need to show three parts. That is, diagonals are equal, they bisect each other, and they bisect each other at right angles. Now I am going to consider the intersection point as E. Now let us consider the triangle ACD and triangle BCD. See, in triangle ACD and triangle BCD, CD is common in both these triangles. CD equal to CD and angle ADC is equal to angle BCD, which is equal to 90 degrees. In a square, every angle is 90 degrees. And AD is equal to BC. Since this is a square, each side is same. Now from SAS property, we can be sure that these two triangles are similar, which means angle BDC is equal to angle ACD. BDC is equal to angle ACD from the similar angles property. Now let us just consider triangle ACD. Now see, in triangle ACD, AD is equal to CD. Since AD is equal to CD, this triangle is going to become isosceles triangle. Since angle ACD is equal to theta, now this is also going to become theta. Now if you consider triangle BCD, this is also isosceles triangle. From that you can say that this is theta. Now this is what we got. Now let us consider just triangle ACD. In triangle ACD, now the angles are theta and 90 degrees. Now let us find the theta. Now in a triangle, sum of angles is 180 degrees, which is theta plus 90 is equal to 180. Therefore theta is equal to 45 degrees. Therefore this is 45 degrees. Now if you see, DE is equal to AD. Sorry. Let's just forget about this. Now theta is equal to 45 degrees. Since theta is 45 degrees, let us consider triangle EDC. See, in the triangle EDC, two angles, angle EDC and triangle angle ECD, both are theta. Now let us find the other angle. Now angle DEC is equal to 180 minus 2 theta, which is equal to 180 minus 2 into theta is 45 degrees, which is equal to, therefore angle DEC is equal to 90 degrees. Now angle DEC is equal to 90 degrees. Here I have shown that this AC and BD intersected right angles. Now let us look at these similar angles. From the similar angles, we know that AC is equal to BD. AC is equal to BD. Since this is a similar triangle, AC equal to BD. See, AC is equal to BD. Now AC and BD are nothing but diagonals. Therefore I have shown that diagonals are equal and diagonals intersected right angles. Now I need to show that intersection is a bisection. Now let us show about the bisection part. Now let us consider triangle EDC. In triangle EDC, two angles are equal, that is angle EDC and angle ECD, which means opposite sides to these angles are equal. Therefore ED is equal to EC. ED is equal to EC. See, ED is equal to EC. Since angle EDC is equal to 45 degrees, now this is going, angle ADE is going to become 45 degrees. Therefore, from triangle AED, you can be sure that AE is equal to ED. AE is equal to ED. Therefore, AE is equal to EC, which is equal to half of AC, which means these diagonals bisect each other at 90 degrees. This is our answer.